Okay, this problem wants us to find dy given that your y is given as this. Now, instead of using the y prime notation, what I'm going to use instead, since we're in the section talking about differentials, I'm actually going to use the dy dx notation on this instead, since they're asking us to eventually solve for a dy. So what are we going to do? We're going to basically take the derivative, but first I'm just going to go ahead and rewrite this as 6x to the 1/2. And then what I'll do here is apply the power rule, and I can get the dy dx. Power rule here, 4 comes down, I have 4x to the third, and then minus this, I'm going to multiply that. 6 times 1/2 is 3, so I have 3x, subtract 1 from the power, and I get negative 1/2. So I have this complete. What I'll do next is I'm going to just simplify it. 4x cubed minus 3 over the square root of x is what I can rewrite that as. But they ask us to solve for dy, and what I mentioned before in the previous video, dy and dx are considered as two separate variables. So I'm going to multiply both sides of the equation by dx. By doing that, that's going to allow me to get dy by itself. So I'll get dy equals 4x cubed minus 3 over square root of x, but then all that's going to be multiplied by dx. So again, I treated that as a separate variable. If you want to cancel it out, you do the same thing you would do in algebra, multiplying both sides by d of x. That would clear it out and put it here. So this would be your final answer for dy. Okay, this problem we also have to find our dy dx. However, we don't have y isolated, so whenever that happens, you got to use implicit differentiation. We're going to do that in this case. The first term requires us to use a power rule. So power rule, we're going to do first thing times the derivative of the second. So we want to do the derivative of y cubed. 3 comes down. That'll turn into y squared. But don't forget on these problems, because we don't know what the y is, that's technically considered something else on the inside, not an x. We got to use a chain rule here. So 3 comes down square. That's the outside function, but then we have to multiply it by the derivative of the inside function, which is going to be dy dx. Again, you want to use this notation instead of y prime. Then we got the rest of the product rule here, plus the second thing, y cubed, and then times the derivative of the first, you get 1. Now this one doesn't require a chain rule because we're taking the derivative with respect to x, so we're just going to do normal power rule there. 3/2 times 8, that's 24/2, that's 12. 12x to the 1/2, because you'll subtract 1 from 3/2. And then this is by itself, the derivative of y, that's going to turn into dy dx. Now the next thing we're going to do is we have to put all the terms that have dy dx in it. We're going to leave that on one side of the equation. Everything else we're going to move over to the other side. So I've got 3x y squared dy dx here, and then I'm going to subtract this one minus dy dx. Everything else I'm going to move across the equal sign. So I'm going to put this over, for this one I can write that as a square root. So I'm going to do 12 square root of x and minus y cubed. Again, both of these go across the equal sign. Now I'm going to factor out a dy dx. So if I factor out dy dx, then we get 3x y squared minus 1. And then I have the rest of this. And then finally what I'll do is divide both sides by that. We'll be able to get our dy dx. Okay, so dy dx is equal to 12 square root of x minus y cubed all over 3x y squared minus 1. Now, what you need to do then is solve for dy, which means that again we're going to multiply both sides of the equation by dx. So if you do that, you get dy is equal to 12 square root of x minus y cubed all over 3xy squared minus 1. And then all this will just be multiplied by the dx in the bottom. So again, we cleared out the fraction by multiplying by common denominator dx, and then we got that on that side. Therefore, this is your answer, solve for dy.